Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. So I'm continuing my O-level past papers session, and this time I've selected IGCSE Chemistry 0620. So today we have paper 6, which is alternative to practical. The variant I've selected is 61 and it's of May-June 2024. The total time is 1 hour. You have to answer all the questions on the question paper. No additional materials will be provided to you. You can use calculator. The total mark for this paper is 40. Important thing for this paper is that you are provided with the notes for use in qualitative analysis. And this is the list. This is a test for anions. We have the list for test for aqueous cations. Then you have test for gases as well as flame test. So let's start the paper. Here's question number 1. A student carries out a titration to find the concentration of a sample of dilute hydrochloric acid. The student adds 25 centimeter cube of aqueous potassium hydroxide to the apparatus labeled A in figure 1.1. So here's figure 1.1. You have two apparatus, apparatus A and apparatus B. Apparatus 25 centimeter cube of aqueous potassium hydroxide. And B is volumetric pipette. The student has the indicator after the volume of the 25 centimeter cube. Is the indicator after the volume of the 25 centimeter cube of the the one. Explain why. Can you please highlight time? It's in your syllabus. See, describe how the student can determine the volume of dilute hydrochloric acid used in this titration. Definitely, students need to note down the initial and final burette readings. Then, in order to get the volume used, the student needs to subtract initial reading from final reading. So you write, note down initial and final burette readings. Subtract initial reading from final reading. Moving to next part, which is part D here. The student observes the color changes that occur as they add dilute hydrochloric acid from the beer. State one other thing the student should do as they add the dilute hydrochloric acid to the aqueous potassium hydroxide. Student need to shake or swirl the flask in order to mix the contents. Shake or swirl the flask. Or to mix the contents. Move to next question, which is question number 2. A student investigates the temperature change when magnesium reacts with dilute sulfuric acid. The student does 5 experiments. Experiment 1. Use a 25 centimeter cube measuring cylinder to pour 20 centimeter cube of dilute sulfuric acid into a boiling tube. Use a thermometer to measure the initial temperature of the acid in the boiling tube. Record the initial temperature. Add a coiled 5 centimeter length of magnesium ribbon to the acid in the boiling tube. At the same time, start a timer. Continually stir the contents of the boiling tube using thermometer. After 45 seconds, measure the temperature of the mixture in the boiling tube. Record this temperature. Rinse the boiling tube with distilled water. Experiment 2. Use the 25 centimeter cube measuring cylinder to pour 20 centimeter cube of dilute sulfuric acid into the boiling tube. Use a 10 centimeter cube measuring cylinder to add 2 centimeter cube of distilled water to the acid in the boiling tube. Place a bung in the boiling tube and invert the tube to mix the acid and water. Use the thermometer to measure the initial temperature of the contents of the boiling tube. Record the initial temperature. Add a coiled 5 centimeter length of magnesium ribbon to the contents of the boiling tube. At the same time, start a timer. Continually stir the contents of the boiling tube using the thermometer. After 45 seconds, measure the temperature of the mixture. Record this temperature. Rinse the boiling tube with distilled water. Experiment 3. Repeat experiment 2, adding 4 centimeter cube of distilled water instead of 2 centimeter cube. Now they have changed the volume of water used here. Experiment 4. Repeat experiment 2, adding 6 centimeter cube of distilled water instead of 2 centimeter cube. Experiment 5. Repeat experiment 2, adding 10 centimeter cube of distilled water instead of 2 centimeter cube. A. Use the information in the description of the experiments and the thermometer diagrams to complete table 2.1. Now we have experiment 1, 2, 3, 4, 5. Now the volume of sulfuric acid added in all these experiments, they are saying, which is 20 centimeter cube. So I will write 20. The volume of distilled water, they have changed the volume of distilled water. So initially, they don't have added any distilled water, so it must be 0. Then we have 2 centimeter cube of distilled water. Then you have 4, 6, 10. Okay. What about the temperature after 45 seconds in each experiment? Looking at this scale, in the first one, you have 37 degrees centigrade. So I will write 37 here. Second one, we are having 34 degrees centigrade. In third, we are having 31.5. Fourth, we are having 30 degrees centigrade. The last one is 25, 26, 27, 27.5. We need to find the temperature increase in each case. So what I will do, I will simply subtract 25 from 37. 37 minus 25. So you will get 12. Temperature increase will be 12 here. What about other experiments? Experiment number 2, 34 minus 25.5. You will get 8.5. Here we will get 8.5. In experiment 3, 31.5 minus 25.5. It's 6. Experiment 4, 30 minus 26, it must be 4. Last experiment, 27.5 minus 26, it must be 1.5. B1. State which experiment 1, 2, 3, 4 or 5 had the smallest temperature change. It's very easy if you look at this. It's experiment 5. Look at the temperature change, which is 1.5. So I will write 5 here. Number 2. Explain why the temperature change was smallest in the experiment you have given in B1. So definitely you are having largest volume of distilled water used here. That's why you have smallest temperature change in the experiment. So I will write largest volume heated. C. Complete a suitable scale on the y-axis and plot your results from experiments 1 to 5 on figure 2.1. Draw a line of best fit. So for the temperature increase, I am taking these scales. I am taking 2, 4, 6, 8, 10, and here we will be having 12. So now plotting the graph. So at 0, you have 12 degrees centigrade volume of water against volume of distilled water. You have 12 degrees centigrade. And for experiment 2, it's 8.5. So this one for experiment 1. Experiment 2, 8.5, it must be here. I've already drawn the graph, so I'm going to show it to you, the graph I've drawn. This will be the final graph you will get after plotting all the points correctly. This is experiment 1. This is 2. And this is 3. This is experiment 4. And this one experiment 5. D. Use a graph in figure 2.1 to deduce the temperature increase when experiment 2 is repeated with 7.5 centimeter cube of distilled water instead of 2 centimeter cube. Show clearly on figure 2.1 how you worked out your answer. Now, if you're repeating this experiment 2 with 7.5 centimeter cube of distilled water instead of 2. Seven point five. Experiment 2. So the volume of distilled water is 7.5. It must be here at this point. Like that. This will be the final for 7.5 centimeter cube of distilled water. So the temperature increase, you will write it must around 3 degrees centigrade. Moving to next part, which is part E. The average rate of temperature increase in each experiment is calculated using the equation shown. Average rate of temperature increase is equal to temperature increase by 45 seconds. Calculate the average rate of temperature increase in experiment 1. Give units for the rate we have calculated. So the average rate of temperature increase in experiment 1 is 12. And the time is 45. So I will write 12 by 45. So what you will get? You will get 12 divided by 45. 0.266. 0.266. And the units must be centigrade per second. F. Part 1. Explain why the results of experiment are more accurate if the boiling tube is wrapped in cotton wool. It's of 2 points, so you have to write or give 2 points here. Any two from. Definitely, it reduces or prevent heat loss. Reduces or prevent heat loss. What else you can write? It traps heat. In this way, it's trapping heat. Act as insulator. It's acting as insulator because it's reducing the loss. It means it's acting as insulator. You can also write, if you want, prevents temperature decreasing. So any two from these. Number 2, explain why a 25 centimeter cube volumetric pipette cannot be used to accurately measure the volume of the distilled water added. So we are using different volume in each experiment. Different volume used in each experiment. That's why you can't use volumetric pipette of 25 centimeter cube. Number 3, state one other way in which the apparatus can be changed to give more accurate results. And use Barrett instead of measuring cylinder. G. Sketch on figure 2.1 the graph you would expect if all of the experiments were repeated using a 2 centimeter length of magnesium ribbon instead of 5 centimeter length. Label your line G. So definitely if you are having less centimeter cube of magnesium, temperature rise must be low. So you will be having this kind of graph here for 2 centimeter of magnesium. Question number 3. A student tests two substances, solution E and F, solid F. Test on solution E. Solution E is aqueous chromium 3 bromide. Solution E is divided into two portions. Record the expected observations. A. To the first portion of solution E, the student adds aqueous sodium hydroxide dropwise and then in excess. Observations adding dropwise and observation in excess. Definitely is having chromium 3 ions. So you will look for the test of chromium 3 ions here. Test result, here's chromium 3 ions. So with aqueous sodium hydroxides, green PPT, which is soluble in excess. So you write green precipitates and precipitates dissolves or soluble in excess of sodium hydroxide. Part B. To the second portion of solution E, the student adds about 1 centimeter cube of dilute nitric acid and a few drops of aqueous silver nitrate. Observations. This must be the test for bromide ion. If you look at the negative ions test, an ion means negative ions. Here's bromide ion. The test is dilute nitric acid followed by aqueous silver nitrate and you'll get cream PPT. So you write cream PPT for observation. Cream precipitate. Test on solid F. Table 3.1 shows a test and students' observations for solid F. Table 3.1. Test 1. Heat about half of solid F in a boiling tube until there is no further change. Observation. The white solid forms a colorless liquid. Steam comes out from the boiling tube and condensation is seen at the top of the boiling tube. After a while, the colorless liquid becomes a white solid. Test 2. The remaining solid F is dissolved in water to form solution F. Solution F is divided into three portions. To the first portion of solution F in a boiling tube, add aqueous sodium hydroxide dropwise and then in excess, warm the product and hold damp red litmus paper at the mouth of the boiling tube. In observations, we see there is no change initially, then the damp red litmus paper turning or remaining red. There is no effect on the damp red litmus paper. Test 3. To the second portion of solution F, add 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. And we are getting white precipitate. Test 4. To the third portion of solution F, add a few drops of acidified aqueous potassium magnate 7. The solution becomes light pink. C. The observations in test 1 show that solid F is hydrated. Describe a chemical test to show that the condensation at the top of the boiling tube contains water. They are asking about the test and result for water. So we have two tests in our syllabus. One is anhydrous copper 2 sulfate. You can either write anhydrous copper 2 sulfate or anhydrous cobalt 2 chloride. So anhydrous copper 2 sulfate is changing from white to blue. If water is there, it will change result white to blue. In case of cobalt to chloride, it will turn blue to pink. Moving to next part, which is part D. From the test and observation in table 3.1, it's not possible to identify the cation in solid F. Give another test that can be carried out to help identify the cation in solid F. It must be none other than flame test. You see flame test? Here is a flame test. It will help in identification of this positive ions. E, identify the anion in solid F. They gave the positive test with barium nitrate, and you know that barium nitrate is used to test the presence of sulfate ion. You get white PPT. So we have sulfate ion present here. So you write SO4 -2 or sulfate. Moving to last question, which is question number 4. A mixture contains 3 compounds: liquid ethanol, solid sodium chloride, solid zinc carbonate. Table 4.1 gives some information about these 3 compounds. If you look at this table 4.1, ethanol soluble in water. What about sodium chloride? It's soluble in water but insoluble in ethanol. Zinc carbonate, it's insoluble in both water and ethanol. Describe how to obtain a pure sample of each of 3 compounds, ethanol, sodium chloride, and zinc carbonate from the mixture. You are provided with the common laboratory apparatus. Total mark for this question is 6. So first we can ethanol. So I'm writing to obtain ethanol. By filtering a mixture. As they have already mentioned, that sodium chloride and zinc carbonate are insoluble. So you can easily get ethanol by filtering, and ethanol will be obtained as filtrate. Now, if you look at the information about sodium chloride and zinc carbonate, we are left with sodium chloride and zinc carbonate in the residue. Both of these are insoluble, they will be put as residue. So zinc carbonate is insoluble in water, but sodium chloride is soluble in water. So what we will do, we will add distilled water to the residue. Next step, add distilled water to the residue. Then warm or stir the mixture. Warm or stir the mixture so that sodium chloride will dissolve completely in this. Next step must be filtration. Filter to get zinc carbonate as residue. You need to wash the residue also with distilled water. Remember, you have to wash it with distilled water, not with tap water, because tap water contains impurities. Distilled water is the pure water. Wash the residue with distilled water. Then what we will do, we will dry the residue. to get zinc carbonate. Now, we need to filtrate. So heat the filtrate, cool down or crystallize. This will be the final steps for this experiment. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.